Today I'm taking a look at a few Internet of Things open source projects to see how ready they are for the IPv6 world. So if you followed my channel for a while, you probably know that I am slowly moving everything on my network from dual stack v4 v6 to single stack v6. Of course that takes a long time. With around 100 devices or so, not everything is ready. So today I'm testing out 3 specific open source Internet of Things projects that I use in my house. So those things are ESPHome, Tasmota firmware, and WLED firmware. Now all of these things are open source projects for the ESP32, ESP8266, those kinds of microcontrollers. And these are not like software only projects that run on a server, run on a Docker container, so they can't rely on the good IPv6 support of Linux. They kind of have to do a little bit of stuff on their own. So the first project I'm going to pick on today is ESPHome. Now, this is really commonly used in the home assistant community to build semi-custom firmware images for ESP8266 and ESP32 and a few other popular chips. In general in ESPHome, you're not writing code yourself. You're taking these components which support your favorite sensors, your favorite protocols, etc., and you're combining them in a YAML file to build up your custom image. So a few years ago, I built a water meter for my house. Well, I bought the meter unit itself. So I have 2 water meters in my basement now. One measures cold, one measures hot water. They just have a little reed switch that pulses for every 1/10 of a gallon. So I built a little sensor node with an ESP32 PoE. This is powered over Ethernet and communication over Ethernet too. And so this guy is hooked up to 2 digital lines that are hooked up to the water meters, hot and cold, pull-up resistor, really simple bit of hardware. And so I wrote the code for that myself, but I'm trying to recreate that now in ESPHome to see how it'll work IPv6 only. So here's the config I got. It's called my water meter, based on an ESP32 PoE board. Don't worry, I'm going to change these codes later. It's just my test device. I've got it set up for wired Ethernet instead of Wi-Fi. There's also a Wi-Fi component if you want to use Wi-Fi instead. And I've told it to enable IPv6 and require at least 2 addresses to be considered connected. So in IPv6, of course, we have more than one address. We basically always have a link local address and possibly more from that. So requiring 2 addresses means we need to have an LLA, link local, plus something from a router. So that'd be either a ULA or a GUA, unique local or global unicast. You could also set this to 1 if you want your automation and IoT stuff to be in a purely link local network, and that would be fine. But I'm testing here with a router with global unicast addresses today. So I connected it directly over USB. So here it is booting up, connected to my computer over USB. There it is waiting for IP. And then looks like we got an IPv4 address over DHCP, got a gateway, etc., DNS over DHCP. We also got v6, so we got our FE80 link local and our 2601 global unicast. And it looks pretty happy. And we've also got an MDNS host name, so that's a .local, and we could use that to try to connect to it. In case you're curious, here's what that query looks like. So it returned back a record of the IPv4 and also a quad A of the FE80 link local, but it didn't return back the global unicast. So this is kind of common with MDNS. It's possible for devices to return both their global unicast or multiple global unicast and also link local if they want to. However, since MDNS is not a routable protocol, it uses a multicast address that's explicitly link local only. Technically, there would be no point in using a non-link local address for MDNS. So it makes sense to do that, but then again, a lot of people run MDNS gateways that retransmit this MDNS across the network, which is not what's supposed to happen with MDNS and can break things. So using link local only instead of a global unicast could prevent that from working, but you probably weren't going to be doing that MDNS relaying on your network anyway. And here's where we get to our first problem. So remember that min IPv6 address count? Well, here it says ESPHome considers the network to be connected when it has 1 IPv4 address and this number of IPv6 addresses. That's an and, not an or. So I'm going to need the IPv4 anyway, even if I enable IPv6. So I actually dug into the code on this and found where this .got_IPv4 address comes in. So basically when it starts trying to connect the network, it initially sets .got_IPv4 address to false, and it also sets IPv6 count to 0. That makes sense. Then it has these 2 event handlers up here that check every time there's an event, these get called. So every time we get a new IP address, we call got_IP event, and every time we get a new IPv6 address, we call got_IP6 event. And that also makes sense. So up here in got_IP event, we set got_IPv4 to true because we just got an IPv4 because we called the function. And down here in got IP6, we increment the count, how many addresses we have. But then this logic down here says we need to have got IPv4 address and the count must be greater than use network min IPv4 address count. So we need to have both of these to get a connected state here. Now ESPHome does have an issue on their issue tracker which tracks this, so that's a good thing. It looks like there was no traction on it for a couple of years until about 2 years ago. But that kind of coincides with ESPHRESSIF adding drastically better IPv6 support to the ESP32 libraries. So before that it was not very good, but now ESPHRESSIF's IPv6 support is excellent. There's no reason not to support it as a downstream application. But this, I guess, sort of delay in supporting v6 on their end, and projects which use very old versions of ESPHRESSIF libraries, which we'll see later in this video, that can cause some problems where IPv6 wasn't implemented because it wasn't available from ESPHRESSIF at the time, or ESPHRESSIF support wasn't good 4 or 5 years ago now. It's good now and has been for a couple of years, but some of these projects just never did it for that reason. But these guys really needed it for Matter support, so they have been working on it. It's just not entirely finished yet. Here they're talking about RDNSS, how they're going to support RDNSS, which they, I think, do. They just don't support v6 only yet. So another problem I have now is if I close this, this is my device and it shows up as offline. And I can't find it because ESPHome itself doesn't have a v6. So here's the system I'm running ESPHome on, and I don't have a v4 address, I just have v6. So this GUI is trying to reach out to this system over its v4 address and it can't. So just added v4 to this container here. So now I have a v4. Let's see if that brings ESPHome back to living. So I restarted ESPHome and suddenly this guy's online. So now I should be able to look at his logs, and there we go. So he needed an IPv4 address when the program started, not just in the future. So somehow it wasn't binding properly with v6 only. One side of the v4 had to also restart the service to bring it up, and now it can find the device and work properly. But that's not working at all over v6. So even if the device goes v6 only, the download protocol, the remote management protocol, that's not looking at the v6 addresses. Even though I'm pretty sure it's working on MDNS. So I'm not sure why it's not looking at those quad A records that it's getting over MDNS. Maybe it's doing something wrong. So that's the state of ESPHome right now. Reading the ESPHome code, they have some code here that does zeroconf, which is MDNS networking. And they've got a number of calls that definitely hardcode v4 here. So host resolver, I'm not actually sure what this function does, but it has a function that returns if it has an IPv4 address. So something is checking that it has a v4 address. Here when it resolves a host name, it appears to be doing it properly. So it says IP version all, but maybe it's just not starting up the resolver at all because it thinks it doesn't have a local address to bind to. So host resolver needs a v4 address, even though the underlying library, zeroconf, doesn't. So here's the library they're actually using, Python zeroconf. And they actually say they support v6 and they support its dual stack sockets, and aside from a localhost bug, it seems to work fine. So these guys are specifically not starting up their client unless they have a v4 address ready. Next one we're dunking on today is Tasmota. Tasmota is an open source firmware for the ESP32 and ESP8266. And it was originally called Sonoff Tasmota because it was specifically for reflashing Sonoff devices, like these two I have here. But now you can use it for all kinds of off-the-shelf devices that use those two chip families, or even your own custom projects. So here are two devices I have around my house. These are spares. This is a 4-channel relay module with Wi-Fi. It can take AC input or DC input and has like mains voltage contacts. I use it for garage doors. Also got these little smart plugs here. This is a power monitoring smart plug with a US outlet. They also have an even cheaper one that's like $9 each that does not have power monitoring, that has a wide variety of outlets. I have some of those too. These are more useful though, and they're only a few dollars more. So these guys both have the ESP8285, which is a derivative of the 8266, so the older chip. So I go over here to the website, and we look for IPv6. They have a whole page on it, on their IPv6 support. So, IPv6 support is by default on ESP32, and requires a custom build for ESP8266. It does make sense. The ESP8266 devices have much less flash memory for code, and enabling v6 adds a decent amount of code space. So they've chosen to disable it on 8266 to limited space and enable it by default on ESP32. Tasmota supports IPv4 only networks legacy and also dual stack networks. However, it will crash after some time, maybe fixed in the future. I think this is related to the DHCP server, actually. And it might be DNS related as well, but I haven't seen this yet. I've been looking at it still. They also have instructions on building with 8266, and I actually went through this process as well to build a custom build that had LWIP2 with IPv6 and use IPv6 enabled. So I have a Tasmota guy flashed here. He's running the latest version. This is Tasmota 32 because we're on ESP32. And if I hit information, do I have v6? Yes, I do. So actually, it supports both Wi-Fi and wired Ethernet. I'm only connected to Wi-Fi right now. But out of the box, it got a global address, it got a local address, and it got a v4 address. So out of the box, on ESP32, working just fine so far. Now, what about that v6 only bug? Where does that come in? So I think the configuration's under Other. So I actually can't find the IP configuration here. But Tasmota has a console, so I could go to the Tools console and look at the values here. So I ask it for IP address 1. Shut up, Edge. And then it'll tell me what the address got, but it's set to 0.0.0.0. So what Tasmota's done is, in their configuration structure, they store your static IP address, static subnet mask, 2 DNS servers, and a gateway. So 5 IP addresses. That's why it's called IP address 1 through IP address 5 for some reason. Basically, if these numbers are exactly 0.0.0.0, then it will look for DHCP. Otherwise, it will do static. And so my network had found DHCP. And I think the bug they're saying is that when you don't have DHCP, it'll eventually time out after trying a whole bunch of times and crash. So what I did to fix this is I just set it to a invalid IPv4, and it'll come up, bring up the IPv4 stack with an address that's not used, and it won't care. So I set this to, for example, so I set it at 127.0.1.1. That's technically a loopback address, but it's not like the loopback address. So just for the curious, this guy comes up over MDNS as the IPv4 that I just set, as well as his link local and his global unicast. So I don't have it set up right now, but Tasmota actually supports both Wi-Fi and wired at the same time. And if you set both of them up, it'll return both of its link locals on Wi-Fi and wired, and its global unicast on wired, and its v4 on both wireless and wired, all over MDNS. So it's pretty smart. So now I've got my v4 set to nothing. My Tasmota blah blah.local still works fine, and it seems like there's no issues. So go here and I do Tools. Not able to resolve IP address. Okay, so I can't do DNS because that failed. Because I don't have a DNS server because it was looking for it on v4. So that's a problem. But for a local network, that's not the end of the world, especially if you're just connecting to just Home Assistant. And information, yeah, so we got this. Is our IP address. The only DNS servers are the ones we get over DHCP are static, so it's not getting DNS from RDNSS. But aside from not getting DNSS from RDNSS, I think it's doing everything correctly. So aside from that DNS quirk, it seems like Tasmota is doing really well for IPv6 support, at least compared to the other Internet of Things that I've tried. So good job for Tasmota. They're based on Arduino as well, which is one of the reasons that WLED claimed that they could not do v6 for a long time. So let's check out WLED then. So here's WLED. So it's a project, again, for ESP8266 and ESP32 for NeoPixel type strips. So obviously these strips have grown a lot over the years, but it's really designed for graphic effects. So I actually use WLED for these strip lights here. Maybe I'll throw in some B-roll of these strips. So these light up my desk. They can change color. If I go here to the UI, so they're currently set to a nice orange, which is sort of like my color. But I could set them to green. Do I look good in green? How about blue? Dark blue, pink. I'll go back to my color. So anyway, you can do a whole bunch of effects too. So they have like effects, rainbow, all kinds of LED stuff. Let's just go back to solid and yellow. So I am using a board that I bought from a guy named Quindor. He has a YouTube channel. I'll throw in some B-roll of the board that I'm using. Basically, it's an ESP32 based board that has the power fusing and stuff to pass through 12 volts or 5 volts to these strips, and to down power the 3.3 volts for the ESP. He also sells options with wired networking. So a lot of people use WLED firmware to do complex like audio sync networking or like time synchronized stuff. And so having the ability to use wired Ethernet instead of Wi-Fi is really important to them, so they can have low latency and low latency across multiple devices basically when they're sending commands. So I'm using it wired Ethernet just because I prefer wired over wireless. But wired doesn't come into play for this story. So how goes IPv6? Well, if I go here to config, we can see what the IP address is, and we're going to go to, I think it's under Wi-Fi setup. Yes, I'm already set up to a network, so it's not showing me my password, but they're again using 0000 to mean DHCP and gateway and mask. So I've left that there. They also support MDNS, which is nice. And I currently have a v4 address, and they can also act as an access point or some other things. And I'm using the Quinn LED ESP32. So no v6 in here at all. So we resolve this DNS name, and we get just an A record. Now that's it. No v6. Search for IPv6 in their docs, and we get nothing. So we come over to the GitHub, and we search for IPv6. So it looks like we have, I'm not signed in, so I can't do a code search. But issues, someone requested it, and, oh, that was me 22 hours ago. Who else requested it? MDNS, UDP sound sync. Yeah, so not really discussed here. So UDP sound sync, they think they can multicast better with IPv6. And here, these guys also want MDNS over IPv6 for routing reasons. And then obviously I want IPv6 here with my feature request. The big thing blocking WLED firmware from supporting IPv6 properly is they're using version 1 of the Arduino ESP framework. The current version is version 3. So version 3 has feature parity between IPv4 and IPv6. Version 2 had full support for IPv6, and version 1 had full support for, well, I won't say full support. It didn't support RDNSS back in version 1, and I don't know. They're using version 1, and version 1 did not have good v6 support, but version 1 is also like 4 years old. So they really need to upgrade their versions. The reason they're so hesitant is because they support a wide variety of target boards, many of which have low memory, especially on ESP8266, and these LED patterns take up a ton of space. So because they're compiling in so much stuff, they are really hesitant to go to newer library versions because of the code size impact of that. And just basically no one wants to do the work to change the code to go from library version 1 to version 2 to version 3, which is what it would take to have good v6 support for them, I think. I looked at the code, and I think with the library version 1 they're on, it's not going to really do v6 support. If they were on library version 2, it would be much more possible. And some of their builds use version 2 because they're using newer boards or newer chips that weren't supported back in library version 1. But that's not a consistent thing across the project. They're not using the same library version in Platform I/O all the time. Now that said, I still love WLED firmware for my LED lights, and I'm not going to get rid of it, but I kept this bug report open. And essentially, as soon as they migrate to library version 3, I'm willing to put in the work to do all the rest of the work to get v6 support in here. But I'm not going to do the library migration because that's too much work for me. So that's all I've got for testing today. Now I will say, I don't want anyone to feel like I'm picking on these 3 specific open source projects. Of all of the Internet of Things gadget type things I have in my house, these are actually some of the best ones. So for example, I have a sprinkler timer. It's only about 3 years old, and it doesn't even do 802.11n. It still needs 802.11g. So let's think about the IP support in that thing for a second. I also have like a PLC in my house that controls a sewage pump. That barely even supports IPv4. It doesn't even do DNS. You actually have to type in all the IP addresses, like ... at a time. So these open source projects are doing relatively well, and I'm glad to see them moving along in their IPv6 support. WLED is a little bit behind the other two, but they're getting there, they're making progress. So if you have any other categories of devices or specific devices you think I should test, especially open source projects that I can get to and access easily, I would love to hear about it in the comments. You can also message me in my Discord, server link down below for that. I have a Ko-fi if you want to give me any tips. It's kind of like Patreon, but only a one-time thing. I really appreciate that as well. And as always, I'll see you guys on the next adventure.